Alright, so now in this video we're going to talk about the recursive method flood that is going to be used to fill our image with a certain color. Some algorithms do take in an image, ours does not need to, in fact, so you can remove this. Because there is a field, we have stored our image in a field, this method just has access to it. And so we don't need to constantly send it back to the image over and over and over again, or the method over and over and over again. So let's talk about the steps for this recursive method. The first step is we have to do a bounds check. Because an image is just like an x and y plane of pixels, and so we can go out of that image array very easily. So if the x dives below 0, it will be outside the bounds of the image, so we need to stop the method if it hits the edge of our image. Then we need to check to see if we're on the old color, the color that we're trying to flood. So check for old color. And if we are on the old color, switch to the new color, and finally we're going to flood the surrounding pixels. So just think through what's happening, right? The mouse is clicked at an X and a Y point, and so that whatever is clicked represents the old color, so we will get the old color from that. Whatever the sliders are set to represents the new color, and so our paint panel will send these over, okay? This information will be sent to us by the paint panel. Here's the color they clicked on, here's the color that I'm currently set to, and here's where they clicked, so that you can do your job. So first off, you have to do a bounds check. You have to say if x is less than 0, we want to return. That means like the method needs to be done. And if you have just a single line of code that follows an if statement, you don't need the braces, the curly braces. You can just have that one line for the convenience of writing. So similarly, if y is less than 0, we want to return. We want our method to be done so that we don't get an out of bounds check on our image. And if x is greater than image.getWidth, greater than or equal to image.getWidth, because remember the width is always 1 greater than the final index, and if y is greater than or equal to image.getHeight, we also want to return. We want to exit our method. So now we need to check for the old color, so we say if image.getRGB, that's one of the methods that you don't know about yet, but I know about it. If that equals the old color, or if it doesn't equal the old color, excuse me, if it does not equal the old color, we want to return. We want to leave the method. We say, okay, we encountered a color outside the puddle that we're trying to fill, or the area that we're trying to fill, so we return. But if it does equal the old color, then we want to say image.setRGB to XY new color. We want to set that one to the color with which we're trying to flood the image. And then finally, we want to flood all the surrounding pixels. So we've already done a bounds check, so we don't need to do an additional bounds check here. We can just say flood x minus 1, so we flood the one to the left at the same, or I'm sorry, to the one row above, with old color, new color. And we also want to flood x plus 1, y, old color, new color. And we also want to flood x comma y minus 1, old color, new color. And we want to flood x, y plus 1, old color, new color. And that is our completed algorithm. In the same way, that we remove the buffered image, I believe we can remove old color and new color because they're only used internally. So if you want to further simplify this, and I'll probably do that in the next video, you can remove everything but just the X and the Y values. So let's see, I think that's it for this video. Next video we'll actually add it to the paint panel so that we can begin drawing with it.